Again, Let's Talk Forensics with Pastor Dan. Today we're looking at trajectory of a shot. A little bit of math going on, so you're going to need a calculator to do some work here. Now, trajectories are the distance and path a shot takes getting to its target. All right? Now, there can be three main equations that we're going to use. We're going to work them through. Don't get freaked out, but this is where math and science become fun, in my estimation. All right, here's where we go. The world record shot. This just recently happened. Before that, it was a Canadian named Craig something or other. He had shot about 2.14 miles away back during the Gulf War and the Persian Gulf situation. Just recently, our Ukraine sniper, and I don't have his name, shot over 4,000 meters. He did that with a drone and AI assistance, so that way 2.5 miles. That's a world record shot ever taken to this point. Now, to do a trajectory, we're basically looking at the angle of this. This is the angle that the bullet entered. This little angle right here. So talking about the angle of incidence, we're talking about that angle that we make with the ground to where it enters its target. All right, now, here's the first problem we'll look at. Determine the height of a shot if it hits a victim who is 6 feet tall from a 120 feet at an angle, the angle of incidence of 22.62 degrees. So these are three equations we're going to need. We're going to need a Pythagorean theorem, a squared plus b squared equals c squared. We're going to use a distance equation. Distance is equal to r, rate, speed, times time. And then a little trig here, tangent, which means the opposite side over the adjacent side. So here's our little picture. This is our adjacent side. This is our opposite side. And if we ever get, this is called the hypotenuse side of trig functions. And then this would be A, this would be B, this would be C. All right, so let's get started doing this problem. So he's 6 feet tall. So we're going to knock that one out first. The distance is 120 feet, and the angle of incidence we again said was 22.62 degrees. So which equation are we going to use first? We're going to use the tangent equation. The tangent of 22.62 is equal to opposite over adjacent. Now you take your calculator. 22.62, the tangent of that is 0.417. Is equal to opposite over adjacent. Now we got a division there. We want to get rid of that. So we're going to multiply both sides up. That value is 120. We're going to multiply up to get rid of that fraction. Multiplying it will eliminate that. So we're going to have 120 times 0.417 is my opposite side. You take your calculator, take 0.417 times 120. You get 50.04. Actually, we're just going to call it 50 feet. So that's how high up we're looking at. But remember, we got that 6 feet additional. So the shot was actually 56 feet. Between the fifth and sixth story, because a story is about 10 feet. All right, now let's find out next the distance, and the speed of the bullet. All right, so what we're going to do is go back again. We're looking for that hypotenuse, that x side, and we said that 120 feet was a distance. Remember, I said 50 feet was the shot. We're not going to worry about that sixth inside of there. Using that first equation, that Pythagorean theorem I gave you, a squared plus b squared equals c squared. So 50 feet is my A. My B is 120. You take your calculator, 50 squared times 120 squared, or 50 times 50 plus 120 times 120. We get an answer of 16,900. We take the square root of it. You take the square root of that number. We're going to get that it's 130 squared is 16,900. Which means 130 feet. But remember, we're trying to find the speed. So go back to that last equation. So that's this x right here. This is 130. So that equation d equals r of t. We're going to divide both sides by t again. Get rid of that fraction. Just make it equal to r. So r is equal to d over t. Speed is equal to distance over time. Put our 130 feet in, divide by 0.3333 seconds, divide them through, we get 390 feet per second. It's moving. It's going to cover a lot of distance. All right, let's take a look at another problem now. A second victim is shot while sitting. Height from the ground is 4 feet. Angle of incidence 60 degrees. The shot was taken from 100 feet away. What is the height the shot was taken? Take some time, pause the video, see if you can draw it out for yourself. You're going to find I'm not a great artist, so we're going to be stuck with what we get. When you're ready, start this back up again. Here we go. That's my photo. Again, no great artist. All right, so 4 feet, height the shot hits. 100 feet, distance the bullet travels. Angle incidence, 60 degrees. So we're going to do the same thing we did before. We're going to use the tangent equation. Tangent of 60 is equal to x over adjacent, where x is that adjacent side. All right, so we're going to, 100 is the distance the bullet covers. Multiply up, get rid of the fraction. The tangent of 60 is 1.73. So multiply up, 100 times 1.73, just move the decimal places 2 over to the right. We get 173 feet, but remember we have that guy sitting down, so we're gonna have to add 4 more feet. Total distance, 177 feet, basically between, if it's 10 feet, the 17th, 18th floor inside of there. All right. Also determine the distance the bullet traveled before striking the bullet. Again, we're going to look at that same picture again. Okay, so we know that that was 173 feet. So we're going to go back and do the Pythagorean theorem again. So a squared plus b squared equals c squared. A squared was 173. That's this here right here. B is 100. So 173 plus 100 squared gives us 39,929. Take the square root of that. We get 199.8 feet. All right, and then lastly, calculate the distance a shot. Now, this is a different problem. Speed of 299 feet per second. It takes 3.2 seconds to reach. Now, we're going to go back to that original location, but we're not going to have to rearrange it. Just plug it right in there. My speed is 399 feet per second. My distance is 3.22 seconds. We multiply them. Seconds cross out. We get 971.75 feet. If we want that in miles, a mile is 5,280 feet. We put them in that way so they cross out, get our units of miles. We're talking basically 0.2 of a mile. All right. Hopefully that's not too bad. Take care. God bless. We'll be practicing the next. Be good. Bye.